Hello everyone, I'm Adam. I'm a Year 2 student on the Applied Cybersecurity course at the University of South Wales in the Newport campus. And today I'm just going to show you some of the stuff that we've been learning over the past year and first couple of months. Um, so I'm just going to go over the TCP IP model, slash the OSI model, and maybe some creating some packets of your own and encapsulation and all that. So the first thing you kind of need to understand about this before you get into encapsulation is just how the OSI model actually works. So the OSI model in itself is just mostly like theoretical way of breaking down processes, where the TCP/IP model is more of the what would you say, realistic implementation of it. So like for example, these application and presentation and session layers are separate in the OSI model just to help describe what goes on in the application model, if you understand what I mean. So the OSI separates them, but in a lot of protocols, they're all kind of like combined together realistically. So that's basically the differences between the two. But anyway, so if we take like a simple web request to a website, for example, where we can describe how that works. So um, the very first thing that happens is you go to this physical layer. So this physical layer is the actual connection to um, like through cables or through radio, for example. So anything that gives you like a medium of actually like sending data, and then you go to the data link, which is then the way of communicating between devices on the same physical layer, if you understand. So that's like so for example, two computers by connected through Ethernet can both talk through the Ethernet protocol, which is 802.11.3, or like Wi-Fi protocol, for example, is 802.11 dot whatever like version of it is. Like you've got AC, N, B, or that. So then, if you're not on the same data link, so if you're not, so for example, if you're on Ethernet, but then you're trying to talk to something on a different network, then you have to go to the network layer, which is where you would go through your router to the IP address of whatever you're trying to speak to. So instead of talking via MAC, you're talking through IP address now. So this is handled through like routers and things like that, all interconnected devices if they're not on the same network. So once you've figured out how you're going to talk to the thing that you need to get to, then you go to the transport layer, which describes how your devices basically get there in the way that it's supposed to be. So, for example, for the transport layer, you've got things like TCP, which allows you to send data reliably by checking, fragmenting it into separate little parts, and then checking if one of them parts hasn't arrived, then asking the person to resend it and stuff like that. So it makes sure that it gets there properly, all in one piece, in the right order, for example. Whereas another protocol, which is a transport protocol, UDP, or only basically sends the data without verifying anything. It still can verify it if it's valid, but if it's not, for example, it just doesn't care, it just doesn't ask for a resend and doesn't do any extra verification. It can arrive out of order or that kind of stuff. So most things that use this are like non-accurate, like critical applications. So like for example, games will use UDP because it doesn't really matter if the data gets there out of order or broken, because you just need speed, and that's something that UDP is really good at because there's no like overhead of checking if it's right. And then you've got the session layer, which is used for like managing like what would you call it, like connections between people and authenticating them. Not really used in this scenario. Maybe on a website, I guess you could use like cookies or whatever can be used as session. So then once you've gone past there, you then go up to the presentation layer. So if you was using SSL, for example, this is where your data would be, I guess, encrypted. Yeah, I mean, yeah, presentation. So this is where your data would start to be encrypted, and then once it's all in the right format, then it goes off to the application layer, where you actually create your HTTP packet, whatever the send off. So then once it's all bundled together in this big giant packet, then, and all the layers are right, then it gets sent off. And then what happens is it gets done then in reverse. So it arrives at the web server. So I'll do this in another color. So I'll say, right, so it goes around here then to here again. So then it goes to the web server, and then this web server, handles this from the router. So this would be so say like the router's connected to the web server, and then goes to the data link. So then it will have the MAC address of the router, and then from that it determines that the IP that it was sent from was our client IP, and then here it then transport layer. So this is where it would be initializing the TCP connection with us. And then the session layer, so on, not really used, like I said, presentation. So this is where it starts to decrypt the information that we sent, and then here it then, once it's decrypted, it goes to the application layer. So this is where you would see like the actual GET request from HTTP or whatever, and then it goes back again. So that's basically how the layers work. It's a bit complex. It can be kind of hard to wrap your head around, but it's a lot easier to represent it in this way because it's kind of bundled together. So if you represent it this way, it's a lot easier because then you can basically say that, well, you've got the network access, so it's done in a way of, well, MAC addresses, and then if it's not on the same network, then it goes to the internet, and then this is then the host to host, so the transport UDP or TCP, and then it's sent to HTTP or HTTPS, for example. That's a lot easier way to wrap it more than trying to overly break it down through the OSI. But anyway, so now we can have a look at how some packets actually work. So we can see, for example, I've got this Wireshark running here. So Wireshark is a program that allows you to capture and analyze packets. So if I just clear this, right? So the protocol that I'm looking for now is ICMP, which is a layer 3 protocol, because it doesn't actually state how you transfer data. It's just a network-based protocol because it's on top of IP. The IP protocol, which is IP address. So we can have a look at how ICMP packets are made. I've got two VMs here. I've just got a web server and a client. They're both running Debian. So one's got the IP of 129 and the other one's got the IP of 128. You can see here 129, and then this one's got the one of 128. So for example, we can just do a simple little ping request like that. And you can see 4 packets there. How many is it going to do? 6, 7, 8, 9, 10, 11. Okay, it just keeps going. I forgot about that. Right, 13. So we just sent 13, right? And you can see now all them packets that we just sent are in here, right? And then down here, you've got a little view of the actual hex or the bytes of each packet. So this is what they look like in raw data. And then it highlights the parts, the information that you over, it highlights the size of it, so you can see, like, for example, this is the actual data of the ICMP by here. So this is entirely highlighted, whereas I click this, if I click that, that's what is this? Right, that's the sequence number, but they're 256, and stuff like that. Anyway, so for example, my web server here that I was pinging the client, that sent a type 8 echo ping request. So it sent the number 8 by there. And then it says the checksum. So this is to make sure that the packet actually arrived there correctly. So if this number doesn't match the checksum of this data, then it's arrived incorrectly. Then you've got the sequence number. So if you can see by here, the sequence goes up by the amount that you've sent. And then you've got the that's just in a different format, low Indian. And then above that, then you've got the IP protocol layer. which is you see it's got the source and destination IP. So you see it came from the 128, so the server, and it was being sent to the client, which is this one over here. And then it says the time to live. So this is to make sure that it doesn't go through too many hops, so it doesn't just keep on going till the end of time. Then you've got the flags, which just state like some options that you can have with the packets and things like that. That's mostly the important part. And then here you can see we got the Ethernet as well. So this is the 802.3 that I was talking about. So you see the actual source MAC address and the destination MAC address here. So you can see on the left the MAC address of the client is can't see it, I'm blind. Yep, this one by here ends in A8, and then you can see over here the destination was to there. So if, say, for example, these weren't on the same network, instead of the destination being the actual thing that we're sending it to, that would be the route between it. So, for example, if we had a router, it would be the actual MAC address of the router in between us, basically the first thing that we can use to get out of the network, or the default gateway, for example. And then, yep, so that's that. So once you can see this, you can basically see the layers there. So you see, if I click on this, you see the IP layer starts. Hold on, get it to work. There you go. So you can see that highlighted bit there. Then that's the IP layer, that whole blue highlighted bit. And then this Ethernet, that's the first layer. So you can see how they kind of bundle together now, like according to this layer by here. So you see the data link or the network access layer, but there is this entire row. So that's the first bit of information on the packet, that highlighted blue stuff. And then the IP layer is bundled on top of that. And then you can see the ICMP layer is bundled on top of that. You see it? So that's layer 3. So that's basically how encapsulation works, and then decapsulation works in the reverse order. So what it does is it looks at this layer first, and then it can break it down then into further layers like that. So it just basically does encapsulation, but in reverse. So we can have a go at making our own packets, encapsulating our own packets. There's a really nice Python library called Scapy, which allows you to mess around with packets. That it can be used a lot in security because it allows you to just modify packets as well. So you can do some pretty interesting stuff like art poisoning, and it does packet sniffing as well, and you can do analysis with it. So you can also do like Wi-Fi sniffing and stuff like that. So I made this program earlier. I've made 2 actually. So this one by here. So you can see to do this ping request that we've done in here, we can also do it through code as well. So you just have to create the Ethernet layer. So this is the ether, and then you to add on to a layer, you just do a slash symbol. You see this little slash by here. I'm not sure if it's. Let's try zooming in. Might make it a bit easier to see. So you do a slash, and then you see here. So you do the Ethernet layer first, the IP layer, and then the ICMP layer, and then I'm just using this sendp function to actually send the packet. You have to use the sendp and not send, because that allows you to send layer 2 packets, which is the Ethernet layer. So the destination MAC address that we put will be the 9F, which I think is the server or the client. It's the server. So we're sending it to the server, and then the 128, yep, that's the IP of the server. So if we run this program now by just doing Python udp.py. Okay, I forgot. Dest should be DST. There you go. Okay, ICMP echo request not defined. This is great. Let's get rid of that. There we go. So now you will see our echo request, which is this one. Actually, let me reset that. Right, let's run that. There we go. There it is. and that's the one that we just created. You see here, type is 8, or that checksum. So we can change this information, for example. So we can, on the type, for example, we could do type equals 7. And run it again. You can see here type was 7. So although no, it's not a valid packet, you can modify these packets however you want. You can change the destinations. And Scapy fills in most of the information that you don't really know. So for example, instead of me having to manually calculate this checksum, it just does that automatically. And same with this Ethernet stuff as well. So you know how you got a source and a destination Ethernet. Scapy will just auto detect the source ones, so you don't have to keep typing it in everywhere. So yeah, that's how you just create a basic ICMP packet. You can also create UDP packets as well, and then do any additional layers on that. So say we wanted a UDP packet, it's as simple as doing this, and then saying like I don't know, we'll do a port number of destination port of I don't know 27,000, and then on top of that, then you can put some of your data that you want to transfer. So let's just say hello world. So if we do that, and we run that. Oops, I did UPD. There you go. So that's sent a packet here. And then you can see here, this is our data there, hello world. It's picked it up as an ICMP for some reason, but that's interesting. And then you can see our port, if I go onto UDP by here, destination port, 27,000, same as we typed in. Source port just got a random assigned port. Scapy just generates a random one, I'm pretty sure. And then that's it. And then it got picked up as a ICMP. And then in the UDP part, or actually it's been picked up as DNS, which is even more interesting. And then you can just see our hello world there, and then the hex for it, or the bytes. So that's how you simply create packets like that. You can do any kind of layers. It supports so many layers. You can do NTP, you can do DNS, all different layers. You can do something a bit more advanced as well. So I've got the web server running on this server here. So if I went to 127.0.01, you see there's just a little example web page there. You can also access it from the client as well. So you just use the IP of the server. Oops, 128. There you go. So it can talk. Then we can see these HTTP requests by going in Wireshark and just typing in HTTP here. And then there you go. You see we got one request here, which is the one that we sent. So you see it sent all this information. So get, and then it has different stuff like the host, the user agent, all that stuff to help identify. So that's the HTTP protocol. You can see that's built on top of the TCP, which is built on top of the IP, which is built on top of the Ethernet. So that's how it works with the layers. You can see you can select the different layers there. You see all that part is just HTTP. And HTTP only really works on plain text. So that's all it is basically, is just sending text on top. And then your browser just processes that text. And then the TCP information, you see here the source port and the destination port 80. And then the IPs are the same again, and the Ethernet's the same. So it's pretty simple. If we wanted to create our own HTTP request, we just have to figure out the destination Ethernet, which we know, the destination MAC address, and then we just have to know the destination IP, and then the TCP is going to be kind of the tricky bit, because TCP does like multiple packets in order to basically initialize a connection and send data. So it does like a handshake. So I managed to make a program that does that. I've tried to make it, it looks a bit, if you do Python, this might look a bit weird, but I've just tried to lay it out so it looks easier to read, I guess. So the way that the TCP handshakes work is you do a SYN, and then the server or whatever will respond with a SYN-ACK, which you then acknowledge. Then you send your acknowledge back, and then finally you send your information that you want to send it. And then this I've skipped out a lot more, which is the receiving as well, just because it's a bit more complicated. But basically, this allows us to create our own HTTP packet. So up here, you see you've just got the destination and the source port. I've just chose a random one for now. And the flags just means that it's a SYN packet. So if we look down here, we typed in TCP, we've got a lot of traffic on there now, just because it's picking up SSH. But if you can find them ones from earlier, you see this TCP. You see you got a SYN, then you got a SYN-ACK, then you've got an ACK, and then the data. And then you see you get an ACK and then data back as well. So if you look at the flags in the TCP header, it's the flags. Yep, there it is. So you see the SYN bit is set, and then for the SYN-ACK, then you set the SYN-ACK. So that's all this flags means. S is SYN, A is ACK, then P just means push ACK. So that means you send the data. So let's try that out. Just do Python TCP. Oops, got to do sudo. So then there you go, and then there's our data back. And if I went down here and I did tcp.port equals 80, just so we filter out all the ones. Now I've gotten some retransmission things here. That's just because I don't actually close the connection because it's not worth it. So it's still trying to resend me stuff thinking that I haven't acknowledged it. That's one of the things that I'll keep trying until it can send me the data until I acknowledge it. And then you see here it sends a TCP reset. So you can see where's our request start? I think it's here. In fact, let's do it again. Let's do it again. There you go. So this is our request. These are all the packets that we've sent. So the IP layer bit, that's just our source IP and destination. And then our first SYN packet is by here, this first SYN one. And then you can see with our destination port and our source port is there, 20,378, which is there. Destination, and we've got the IP, destination source, and then the MAC addresses as well. I didn't do the MAC addresses in this one just because, so like for example, this doesn't support layer 2 stuff, so trying not to be complicated. And then you've got our, once you've initialized that connection and or saying that you want to initialize a connection, then you can see the SYN-ACK packet that's sent back from the server here. You see the flags SYN-ACK, so that's the second part of the handshake. And then we send a message back of an acknowledge saying that, yep, we got that SYN-ACK packet, we're good, we're connected now. And then after that, we send a push acknowledge, so we send data to it and ask it to acknowledge that it's received data, which then the server does actually respond and say, yep, I've got data, here's some back. And then that's where it closes the connection. And after that, by doing a FIN-ACK, which is a finalize acknowledge. So here's the actual request that we sent with the data done. So it's just a simple get there, and then the server responds back with this this huge thing, which you can see here better. There we go. Yeah, so there's the actual HTML for that page for there, and then this is just the headers. So that's basically how you craft your own packets, pretty simply. With Scapy, you can mess around with it. Like I said, it supports a bunch of different protocols, NTP, anything DNS. I hope this has helped in some way. So yeah,